Welcome to the Introduction to Electronics, Phase 1, whose basic electrical concepts takes a detailed look at parallel circuits and introduces electronic control components and their related circuits. To understand electronics, you first need a solid understanding of basic electrical principles. Otherwise, it's like trying to drive a nail without a hammer. It's just not going to happen. In our previous electrical courses, we discussed three types of circuits: simple, series, and parallel. Simple circuits have only one load. Series circuits have two or more loads with a single path for electricity to flow. Parallel circuits also have two or more loads, but each load has its own power and ground. In other words, there are multiple paths for electricity to flow. Do you remember open circuit testing, closed circuit testing, and voltage drop? Let's find out. Click on the measurement that represents open circuit testing. Correct. Open circuit testing refers to measuring voltage on an open circuit. Open circuits have no current flow. The open circuit test method is limited and should only be used when closed circuit testing cannot be performed. Remember, open circuit testing can reveal circuit continuity, but cannot reveal unwanted resistance. Hover over each image for a larger view, and then click on the image that represents closed circuit testing. Correct. Closed circuit testing is performed on a complete circuit that provides a path for current to flow. In other words, fuses are installed, components are connected, and switches are set to the closed or on position. In a closed circuit, all connectors and components are connected, and the control device is in the closed or on position. Closed circuit testing is the preferred method for measuring voltage because any unwanted resistance can be identified by a voltage drop in that part of the circuit. Hover over each image for a larger view, and then click on the image that represents voltage drop testing. Correct. A voltage drop test measures the difference in voltage across a component or a portion of a circuit. While voltage drop is usually measured, it can also be calculated when performing closed circuit testing. For example, if 12 volts is measured before the load and 6 volts is measured after the load, the voltage drop across the load is 6 volts. The amount of voltage drop depends on the circuit type and the number of resistors or loads in the circuit.